All right, ladies and gentlemen, welcome to today's class. Today's topic is, or the topic that we are going to be discussing today, pardon me, is evaluating trigonometric functions for non-acute angles, more specifically, algebraic signs of trigonometric functions. So today we're going to be talking about algebraic signs of trigonometric functions. Now, there are some things that we kind of need to go over or review from section 2.2. And if you remember in section 2.2, we were working with finding trigonometric values of function on a Cartesian plane. And in that plane, we had our x's, which was right here, usually are horizontal. We had our y's, and we had our r's. So, and of course, we had our angle of reference, or our z, and we had our 90-degree angle. And we labeled the horizontal line as x. We labeled the vertical line as y, excuse me. So this would be y right here. And the hypotenuse of the triangle, we labeled it as, give me one sec. We labeled it as r. And we established, so we knew that our x, our horizontal we called x, our vertical we called y, and the distance of the or the hypotenuse, or the distance of the origin to the ordered pairs, what we called the r. And we established that in order to find r, we would use the formula that says r squared, or r equals, excuse me, the square root of x squared, the square root of x squared, see if this works now, of x squared, there you go, plus y squared. Okay, so x squared plus y squared. R equals the square root of x squared plus y squared. And based on that, we were actually able to come up with the 6 trigonometric functions that we use when we were calculating the value on a Cartesian plane. And we said the sign was always y over r, y being opposite, r being the hypotenuse. We said that our cosine was x over r, x being adjacent, r being the hypotenuse. We said that our tangent was y over x, y being our opposite, x being our adjacent. And of course, we had the identity functions, which is basically just the opposite. So the opposite of the sine is the cosine. So if our sine was y over r, then our cosine was r over y, r here, y here. Our secant was the opposite of the cosine. So if the cosine was x over r, that means that our secant was r over x. And our tangent was y over x, meaning that our cotangent was x over y. Now, one thing that we established, especially when we were working with coterminal or with quadrantal, non-quadrantal angles, I'm sorry, is that if one of these fractions had a 0 as the denominator, that meant that the function was undefined. Now, today, we're going to continue to talk about this, but we're also going to add some things to it. Now, remember that when we're working with our triangles, we have the initial side and we have the terminal side. And we remember, ladies and gentlemen, that depending on which quadrant the triangles are located is the sign of the x and the y coordinates respectively. Now, in order for us to memorize this, there is an acronym, there's a shortcut, there is, I don't know what you want to call it, and this is actually found on page 81 of your textbook, and it's a little table, and it says all students take calculus. Now, what this table is helping us do is it's helping us determine in which quadrant which trigonometric functions are positive and which trigonometric functions are negative. So let's look at it at each one individually. If we have all, that means that in quadrant, if the triangle or the terminal side of the triangle is located in quadrant 1, then all of the trigonometric functions are positive. And let me erase that. Let me erase this so that way I can illustrate to you guys what I'm trying to say, okay? So let me erase this so I can get some extra space, and that way I can illustrate what I'm trying to get at. So, and let me erase this. What that is trying to tell me is if I have a quadrant or a Cartesian plane, excuse me, and the triangle is located in quadrant 1, meaning right here, or the terminal side of the triangle is located in quadrant 1. That means that all the possible trigonometric functions here are going to be positive. It doesn't matter if it's sine, cosine, or tangent. Now, if I look at the second one says students, and it says quadrant 2, if the terminal side of the triangle is located in quadrant 2, and it's telling me that the only positive function is going to be the sine, and consequently the sine and the cosecant, because remember that the cosecant is the opposite of the sine, okay? So what that's trying to say is that if I have a triangle which is located in this quadrant right here, quadrant 2, or the terminal side of the triangle is located in quadrant 2, if the terminal side of the triangle is located in quadrant 2, then that means that all the trigonometric functions are negative except for the sine and the opposite of the sine, which is the cosecant. If we look at the third word, which is take, it's in quadrant 3, and it means that the tangent and the cotangent. So if it would be that the triangle would be here, down here, in quadrant 3. Now, what that means is that here, all of the trigonometric functions are going to be negative except the tangent and the cotangent. So that means that the tangent would be positive, and because the cotangent is the opposite of the tangent, it would also be positive. And in our last word, which is calculus, it refers to quadrant 4, and quadrant 4 is this one right here. And again, in quadrant 4, what it's saying is that all of the trigonometric functions are going to be negative except for the cosine, and then the opposite of the cosine, which is the cosecant. So it's telling me that all of the trigonometric functions are going to be negative except for the cosine and the opposite of the cosine, which is the secant. Now that we have that basic understanding, we can actually go and use this information to answer example number 1, which is located in your textbook. So example number 1 reads or says, if the cosine of z is negative 3/5 and the terminal side of z lies on quadrant 3, find the sine of z. So the first thing that we need to do is identify what trigonometric function we have, and we have the cosine of z, which is negative 3/5. So we know that the cosine of z in a Cartesian plane is the same thing as saying x over r. So we know that the cosine of z, in this case, because we have a Cartesian plane, because it's telling me that it's in quadrant 3, we know that it's x over r. So that means that we can identify or find a way to find the missing variable or the missing trigonometric function. So in this case, that means that x is negative 3, x equals negative 3, and r in this case is positive 5. So r equals 5. Now, if we go back to the beginning of the video, I was explaining that to find r, we use the formula r equals the square root of x squared plus y squared, x squared plus y squared. And that means that this formula can also be rearranged as r squared equals x squared plus y squared. And basically, guys, what it's saying is that I can, because from this formula, I can get this one. If I squared everything up, that means that I can use this formula to find the missing value. So that's what I'm going to do. I'm actually going to use this formula to find the missing value. And r squared, I know, is 5 squared. And x squared is what I'm looking for. Or excuse me, not x squared, y squared. X is negative 3 squared. And y squared is what I'm looking for. So what I'm going to do now is just say, well, this is 9. And this is 25. And of course, this is y squared. So plus y squared. And what I'm going to do now is rearrange the equation so that y squared, and I take the 9 and I subtract it to 25 equals 25 minus 9. And I am going to subtract that, and that's going to be that y squared equals 16. But I don't want the value of y squared. I want the value of y. So what you're going to do is you're going to square root both sides. And you're going to say, well, the square root of 16 and the square root of y squared. And that's going to be y equals plus or minus 4. So that means that y equals 4. But important piece of the puzzle to the problem, and that way I'm almost there to solve it. It says that the terminal side lies in quadrant 3. Now, if we look at the table, in quadrant 3, the only positive function is the tangent and the cotangent. So that means that all other functions are negative, okay? So what does that mean for our triangle? Well, what I'm going to do is I'm going to erase this real quick. And then we're going to draw our triangles. So because this lies in quadrant 3, and again, all trigonometric functions are negative except for in quadrant 3, which is right here. Quadrant 3 is this one. And because in quadrant 3, all trigonometric functions except the tangent and the cotangent are positive, that means that my triangle is in fact going to be negative. So basically, I'm going to move 3 spaces in x because we know that x is negative 3. So 1, 2, and 3. And this is where we start right here. And this is negative 3. And we found our y. And we know that our y is actually negative. It's plus or minus, because remember that when we're working with perfect roots, it's plus or minus. But because the terminal side lies in quadrant 3, that means that this 4 is going to be negative, and we're going to move 4 spaces down. It's like 1, 2, 3, and 4. So we are then going to have our triangle. And this is where negative 4 would be. We know that r is 5. And we know that this is our reference angle z. And this is our 90-degree angle right here. So again, because it says that the terminal side lies in quadrant 3, which is this one, and from the table that I was explaining a minute ago, all of the trigonometric functions in quadrant 3 are negative except for the tangent and the cotangent, and the problem is asking me to find the sine of z. So again, now that I have that information, now that I have everything, I just need to just plug in or find the sine of z. So the sine of z in this case, remember that the sine of z is what we say y over r. So the sine of z is going to equal the opposite, which is, or y, which in this case is negative 4, over the hypotenuse, which is 5. So that means that the sine of z in this example is negative 4/5. So guys, hopefully this video can explain a little bit better. If you had some doubts in today's class, stay safe, and we'll see each other in our next class. So have yourselves an awesome day.